All right, here we go. A little help video on 4-9. It is huge that you understand how to do these orbital notations correctly. So many of the things that we'll be doing for the remainder of this year, really your entire understanding of Chemistry 1, will relate to your ability to do orbital notations correctly. So much of the other things we do come from this very fundamental aspect of chemistry. The first one we're asked to do, orbital notation for sodium. Looking on the periodic table, we'll see that sodium has an atomic number of 11, which means it has 11 protons, so it should have 11 electrons. We fill up the first level holds 2 electrons because there's one sublevel, the S, on the first energy level. That S sublevel only has one orbital, and that we know each orbital only holds 2 electrons, so the first 2 go in there. On the second level of the atom, there are 2 sublevels, an S and a P. The S, once again, has 1 orbital making up that sublevel. Each orbital holds 2. The P, however, has 3 orbitals making up the P sublevel. Each orbital holds 2, so we're able to put 2 in each of those for a total of 6 in the P sublevel. So now we're up to 10. We have 1 more electron to find a spot for, and that electron will go into the 3s. 1 electron in the 3s. Now, a lot of teachers might have you put the 3p as well and the 3d because the third level has an S, a P, and a D. For this class, you just need to put the sublevels that you need. Over here, you're asked to complete the number of valence electrons this has. Remember, valence electrons are the electrons found in the outermost energy level. The outermost energy level, the energy level number is the first number we see in front of each of those letters. So this is the first energy level. The S and the P here are both on the second energy level. This S is on the third energy level, and there's 1 electron there. So we have 1 electron on the third level. So this atom, sodium, only has 1 valence electron. We're asked to find the Roman numeral on the periodic table of ions. So looking on the periodic table of ions, there is sodium. We go up to the top. Holy cow, it's a Roman numeral 1. It is a Roman numeral 1 right there. So for sodium, it has 1 valence electron, and above sodium's column is the Roman 1. They're both 1s. Here we go. Next one. What is the orbital notation for beryllium? Beryllium, if we look on the periodic table, has 2 total electrons. So we need to find spots for 2 electrons. 2 will go in the 1s, 2 will go in the 2s. Be sure that you're putting your superscripts accounting for how many electrons are on each of those. Some teachers would have you put the 2p and leave it empty. For this class, you just need to put the ones that you're using. So we look right up here. Some teachers might have you put the 2p with no arrows in it. 2 and 2 is 4. That is the atomic number of beryllium, which is also the number of electrons a neutral beryllium atom will have. So how many valence electrons are there? My biggest number here is a 2. So there's 2 valence electrons. We go to the periodic table of ions. We go take a look at the periodic table of ions and find beryllium. Here's beryllium right here on the periodic table of ions. We go up to the top. There's a Roman 2 above the beryllium. There's a Roman 2 above the beryllium. Notice 2 valence electrons, Roman 2. Next one they're asking us to do is gallium. I look on the periodic table. Gallium has 31 for its atomic number, so gallium has 31 electrons as well. Atomic number of 31 means 31 protons. It has to have an equal number of electrons when it starts. 2 go on the first level. 8 will go on the second level. 2 in the S, 6 in the P for a total of 8. The third level, as we learned, holds 18. 2 in the S, 6 in the P, and the D is actually on the third level. It would hold 10. So we can see why the third level has 18. 2 go in the S, 6 go in the P, 10 go in the D. But let's go ahead and go back to the order of filling. 2 go in the 1S, 2 go in the 2S, 6 go in the 2P, 3 go in the 2S, 6 go in the 3P, Why don't we fill the 3D next since it's on the third level? And the answer comes down to Aufbau's order of filling. The 4s has an energy of 4 because when you're in the S, your second number is a 0. 4 plus 0 is 4. The 3D actually has more energy than the 4s. Aufbau says fill the lower energy first. How much energy does the 3D have? Well, when you're in the D, your second number is 2. 3 plus 2 is 5. So the energy of this one's 5, the energy of that one's 4. So we fill the 4s first. The D, if you remember, is made up of 5 orbitals. So we're going to go ahead and put 2 in each of those orbitals, which gets us to 30 total. So we have 1 electron remaining to put in the 4p. Again, superscripts are telling me how many electrons are there. If I add up my superscripts, 2, 2, and 6 is 10, 12, 18, 20, 30, 31. And that's how many I'm supposed to have, 31. How many valence electrons does gallium have? Valence electrons are electrons in the outermost level. The outermost energy level is the energy level with the biggest number, largest number. My largest number in front of any of these sublevels is a 4. So the valence here is 4, the fourth level. The valence electrons are on the fourth level. How many electrons do I have on the fourth level? I have 2 in the S, 1 in the P for a total of 3. We now need to go to the periodic table of ions to see what the Roman numeral is above gallium. There's gallium. I continue upward. The Roman numeral above gallium is 3. So we have a 3 as the Roman numeral and a 3 as the valence electrons. Here we had a 2 and a 2 and a 1 and a 1. Is that Roman numeral telling us the number of valence electrons? Only time will tell. Here we go. Silicon's the next one you were asked to do. 14 for the atomic number. We're just doing the silicon atom, so it would have 14 electrons. 2 in the first. Second level holds 8. 2 in the 2s, 6 in the 2p for a total of 8. Second level's now full. We move to the third level. Third level we know can hold 18. 2 in the S, 6 in the P, 10 in the D, although the 3D gets filled after the 4S as we just saw. But we're not going to need that many. We'll fill the 3S first with 2. So that gives us 2, 6, or 2 and 2 is 4, and 6 is 10, 11, 12. I need 14, so we only need 2 in the 3p. How many valence electrons does this one have? Valence electrons are electrons on the outermost energy level. In other words, the biggest first number. The biggest first number is 3. I've got 2 on that 3. I've got 2 in this 3. 2 and 2, that's 4 valence electrons. What's the Roman numeral above silicon? I go to my periodic table of ions. There's silicon. I shoot upward, Roman 4. Once again, the valence electrons are equaling the Roman numeral for these elements that we are now looking at. We move on to question 5. What is the orbital notation for nitrogen? Nitrogen's number 7. 2 go on the 1s, the first level. First level will have 2. Second level can hold 8. 2 in the 2s. The 2p could hold 6, but we don't need 6. Why? 2 and 2 is 4. 5, 6, 7 electrons. We're full. Or we've completed all the electrons. I'm sorry, we're not full. We've completed placing all the electrons. How many valence electrons does it have? Valence electrons are electrons on the outermost energy level. In other words, the biggest first number down here. First number is energy level. My biggest energy level is at the second level. So the second level has 2 in the 2s, 3 in the 2p for a total of 5. What's the Roman numeral above nitrogen's family? Hopefully you're following the pattern. Nitrogen's right here. It has 5 valence electrons, and lo and behold, it has a Roman 5. So everything we've looked at so far, the Roman numeral is equaling the number of valence electrons it has. Hopefully you're seeing that pattern. Now we're asked to do selenium, number 34. Here we go. 34 electrons to place. First level holds 2, we fill it up according to off-ball. Second level holds 8. Second level has an S and a P. We put 2 in the 2s, 6 total in the 2p, 2 in each orbital. Second level's full. Third level we move on to 2 in the 3s, 6 in the 3p. Now we're going to go to the 4s next before the 3d. Why? The 4s has an energy of 4. As we mentioned, the s, your second number, is a 0. 4 plus 0 is 4. The second number when you're in the D is a 2. 3 plus 2 is 5, so the 4s gets filled first. It totals 4. The energy of the 3D totals 5. So we fill this up with 2. Now we can go on and start filling up the 3D. There's 5 orbitals making up the 3D. Each orbital holds 2. Where are we at in our total numbers of electrons? Please make sure you're putting your superscripts there. 2 and 2 is 4, and 6 is 10, and 2 is 12, and 6 is 18, and 2 is 20, and 10 is 30. We're looking for 34, so we need 4 in the 4p. 1, 2, 3, 4. How many valence electrons do we have here? Valence electrons are electrons in the outermost energy level. My outermost energy number is 4. There's a 4. That 4 has 2 in it. There's a 4. That 4 has 4 in it. 2 and 4 is 6. What's the Roman numeral above selenium? I come down to the periodic table. There's selenium right here. I go up to the top. There it is, Roman 6. We're happy to see that. We go to number 7. We're asked to do chlorine. On the periodic table, we'll see chlorine has an atomic number of 17. That means it has 17 protons. We're doing the chlorine atom, so it would also have to have 17 electrons since it's neutral. Protons must equal electrons. So where do my 17 go? 2 will go in the 1s. That's the level we fill first according to Aufbau. Then we begin filling the second level according to Aufbau, starting with the lowest energy first. That is the s. We put 2 there. The p is made up of 3 orbitals, so we can put 6 total electrons in the 2p. And now we're ready to bounce out to the third level. We put 2 in the 3s. That's 2 and 2 is 10, and 2 more is 12. We're looking for 17, so that leaves us with 5 electrons to go into the 3p. One more and we could have the 3p full. 2, 2, and 2 is 6, plus 1 is 7. We have 7 valence electrons. Valence electrons are electrons on the outermost level. My outermost level is the third level. There's 2 in the 2s, 5 in the 2p, for a total of 7. Hopefully there's a Roman numeral 7 above chlorine on the periodic table of ions. There's chlorine, number 17. We go up. There is a Roman 7, thank goodness. Here it says chlorine wants to be 1 minus. That's very interesting. Why would chlorine want to be 1 minus? If chlorine could get 1 electron, it would fill that p. If chlorine could get 1 more electron and become minus, it would fill that p. That would fill the outermost s and p. That would give it a stable octet. If it got 1 more, it would have 2, and 6 is 8 if there was 1 there. It would satisfy the octet rule. What about neon number 10? Neon has satisfied the octet rule. It is a noble gas. 2 and 6 is 8. When the outermost S and P is full, the octet rule has been taken care of. Neon on the periodic table, we'll see neon has an atomic number of 10. That means it starts with 10 protons. It's neutral, so it would have 10 electrons. 2 in the 1s, 2 in the 2s, 6 in the 2p. That's 10 electrons. How many valence does it have? Valence are electrons in the outermost level. 2 is my outermost level. It has 2 in the 2s, 6 in the 2p. 2 and 6 is 8. We're certainly hoping that the Roman numeral above neon, here's neon. We're hoping the Roman numeral above neon is 8. It is. And neon is chemically stable, so it would never need to have a charge. We'll wrap it up here and continue on the next video.